everyone, this is Ali Reza. In this episode, I will start working on a bit of utility class, and this utility class will grow and grow as time's going on, because that's about compressing stuff. And what do I mean by that? Well, let's make a utility class first. We will call it, wait a second, yeah, we will call it bit masks, okay, or bit mask. Bit mask. And in here I will have a public class, and we will call it byte. In byte, I will say private byte data. Then we will say public boolean get wow boolean get flag, and we send in an int as index, and we return. Now we want to use bit shifting and bit operations. Well, first we know that if we make our data operate with an AND with something, we can get a result. But for that I will use a mask. Well, something like 0b000. And of course this will throw error because now we use project structure, and in project, I think, yeah, this needs to be 7. Okay, apply, okay, and yeah, reload it, and you see that it's okay now. Well, what I'm doing here? Well, I'm sending 0. So if I do AND with data, I won't get anything. But if I flag this one, for example, to 1, okay, our data will go through and say, okay, we have an AND, we return something other than 0, okay? So we want to produce the mask. The easier way to produce the mask is bit shift 1 as index, okay? And yeah, my notes. Then we can say if that is not equals to 0, okay? And we return that. But we need to cast this inside parentheses again. Yeah, if that's not equal to 0, so if any one of those bits return 1, it won't be 0. We can return it. Well, I don't like this. I want to use more bit shifting. And we bit shift down again the amount of index, and we say if that's equals to 1. Okay? Well, this is the same thing. But I forgot to mention that right shifting can be like this. The difference is when you are right shifting in Photoshop, come handy, and well, when you are right shifting, and this is wrong because it's the 3 right shifting one. When you use 2 right shiftings, it will put 1 here instead of 0. Okay, I said brush, yeah, 1, not 0. Okay, this is 1, not 0. And 3 bit shiftings will give you what you saw in here. So this is 3 bit shifting, not 2, my bad. So I used 3 bit shifting so that the uppermost bit will remain 0, because this uppermost 0 sometimes called our sign flag, and well, it tells that if the number is positive or negative. This way I make sure that that uppermost number is 0, and you really certainly didn't need that part because we are just returning a boolean, but I want to keep this template for future because sometimes you don't want just one mask but something like 0, 1, 1, 1, okay? And you would turn it back and you would want it to make sure equals to, for example, 0b, 1, 1, 1, okay? Something like that. So you would want this 3 because the index would fall sometimes, put this guy as the upper mask, the most significant mask, and doing this will make sure that it returns properly. So 1, and of course we want 1. And this is equals to 0b1. Don't get confused. And 0b means that it's a binary. Okay? Now, we say public void set flag at int index, and the boolean is our flag. Okay? What we want to do, we say if the flag is what is your problem? Aren't you a flag? Okay, calling it value should solve it. If value, so if we are sending in true, we want to do something else. We want to do something else. Okay, if we are sending in, we want to do data. We OR it with the bit shifting again for the mask. Okay, and index. What this means, it's OR, not no. Okay. What this means is that, for example, we bit shift it 3 times and we get something like this. Okay, 3 times I said. So the 4th flag here will be 1, and if the data had 1 in here or had 0 in here, both will turn this flag to 1 because we are doing OR operation. Okay? Now what we want to do, if we want to make it false, first we want to do AND, then we want our bit shift, so 0b, well, 0, 0, b1, and in the index, but we want it to be not. So what will this mean? Let's say we are doing bit shift 3 times, so we will get this from inside the parentheses. Then we are doing not, so we get this. Okay? Then we are ANDing it with our data. Let's say our data was 1, 1, or 1. Okay? Because we negated it, we set the flag we want to do the AND on to the 0, but every other thing is 1. So if we have 1 in the data, we will keep it. So the final result will be operating AND between these two will be 0, 1, 0, 1. Okay? And you see, we keep the flags we had on the data, and we just set the flag to not that we wanted, because here we are setting it to false, and that's all we are doing. Then we say public void, no, not common, come on, void, thank you, and remove this guy. Public void, and that is again called toggle flag, and we get the int index. Okay, so we want to toggle the flag. We are not caring if we want the true or false, we just wanting to revert it. Now we say data XOR equals to 1 bit shifted as index. Okay? So what does this mean? First, we get the mask like this. And let's say our data is 1010. Okay? The XOR operation means that we only get 1 in the proper point when we have one of these two bits to be 1. The other one should be 0. So we toggle it. This will return 0, but the bit here, because it's XORing with the bit shift, will return 1 and here. So we keep the data as it is and we're returning this flag. Okay? Now, what if the data was 0? Well, we turn it to 1. So that's what we are doing. Okay? Then, of course, we can say public byte get data to get the whole data, and we return the data. Then we can say public void set data to byte data. Okay, and we say this dot data equals to data. Now, and finally, my notes, where did you go? Come down. Wow, why did you get this big window? Okay, and finally we say public void print debug info. Okay, and here we say for int I equals to 0, I is less than 8, and I plus plus. And I think we would define a string, so string tmp, and here we say tmp plus equals to the oh, this will return it reversed. Okay, nothing here. We will just say log.info. The thing we want is we call flag, then plus I plus, and then plus get flag at index of I. Okay, so this is the byte type, all we can do in byte type. What is the usage, how we can use it? Well, for example, here we can say what did I call it? Bit mask? Yeah, bit mask, and we will speak about bit set in a second. Bit mask dot byte data equals to new bitmask dot byte. Okay? No, not you there. Here. And why are you not happy? Split into declaration and assignment. No. No. Bitmask data. Okay? Then we can say data, yeah, dot set data, and we need to assign a byte. So for example, come on, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay? And why are you not happy? Initialize it equals to null. Then why are you not happy here? Oh, come on. Equals to new. No. Bit mask dot byte there. No, you won't accept it, of course. And what is your problem now? Is not an enclosing class. Dot. No. Come on. How we should assign a class? This should work. Delete. Done. And of course it won't accept it because now it requires bitmask byte. We found bitmask. And if I say dot byte, of course you yell at me again that it's not that, but what is your solution? Again, what is the solution here now? Nothing. This is not an enclosed class. Let me pause the video. Okay, found the problem. This thing here should be static. Okay? Because now it binds itself to bitmask. So the first error is gone. The second error is that we are accepting byte what we are sending int. So even though we are defining the number with 0b, at the backend this is an integer, so we are casting it to byte. Okay, so this is how you can use that. Then you can say data, for example, dot toggle flag at the index of 2, and that means this is 0, this is 1, then this one is becoming 1. Okay, this is how you use them. Now, we define the byte type, and we are sending one boolean. Okay, sorry, so set data. We are sending byte. What if I want to send an array? First of all, let's set this guy. Control C, Control V. But instead of one boolean, I will send in an array. Okay, and an array of indexes. So first I check if index.length does not equals to value.length, we simply return. We don't want to do anything. Now we say for int I equals to 0, I is less than, anyone will do index.length. Then we want to add the I, we will do stuff. Okay, here we cut this guy, we paste it inside, but we will say if value of I, okay, now that then index of I and index of I. So now I can send in an array of indexes and booleans, okay? And then another override that I only send in an array of indexes. Because honestly, an array of booleans wouldn't mean anything on this guy. So here we go, value. Okay? And then we want to be able to set data some other way. Control C. First, we saw that we may get an int by the way we defined it, but we want to cast it to byte, and if we send a number above the 255, we will lose the other flags. That's the way it works. Then I want to accept it, but instead of this, I want to accept a string. Huh. How can I set a string come on, string? How can I set a string to a byte? Well, we can say int length equals to data dot length. Then we say for int I is equals to 0, I is less than 8, because remember, no matter what we are sending in, we just need the first 8. We are working with a byte here, so I plus plus. And then we say this that data dot dot set flag. Why are you not happy now? Oh, because this is not the proper way. Set flag. Come on. Set flag, and we send in index, and the data we are wanting to send, we say if the data we send in dot character at I is equals to 1. Okay, so if it's equals 1, it will send in true. If it's not, it will send in false. So now, for example, I should be able to do this bit mask dot byte test equals to new bit mask dot byte. Okay, and goddamn it with you and your way of doing stuff. There we go. Then we can say test dot set data to this string, for example, 1110011, and that is 4, 5, 6, 7, 8. Okay, and I want it to be able to do this because this will help. This is the proper way many people address a byte. So on here, when we are reading, we can say data dot remove. Do I have that? What do I have? Well, let's move it down. For example, code point, compare, mesh, compare, contact, contains, get bytes. Yeah, replace. The old character is a space. The second character is null. Okay, and does it work? Empty character literal. Okay, that is not happy with null. Nah, it won't work. So space with null, or do it this. There we go. So it will remove the space. Let's see. Where was I? Into factory. Yeah. Then if I set it to this, then if I set test dot debug print debug info. Okay, if I run the game now, I should see some debug infos when we are writing to NBT. Okay, Minecraft came up. Single war And here you see that I got the flags. So how did I got the flags? Well, first of all, it properly removed this guy. Flag 0 is 1. Oh, what the heck? Yeah, it's true. Flag 1 is true. 2 is true. 3 is false. Then 4 is false. And 5 is 5, 6, 7. Okay, I miscount. So 0, 1, and 2 is true. Then 3 and 4 are false. And why do I get one extra here? Huh. I'm losing one here. So this is not working. At least the way we implement it now. So if we want to replace it with null, and we rerun the game, come on, you don't have remove data dot replace split start substrings to character to lower to string to upper trim subsequence get notify wait. Yeah, come on. You should have something like that. And yeah, we crashed because oh. You shouldn't add stuff when you are running Minecraft. So what did we get? Is a crash because I'm sending in a null. So okay, I think it's easy to find what we want. We say Java remove space inside string. Why the space from strings in Java? st replace all. Here we go. There we go. Okay, let's try it. And it was replace all, so there. And let's try it. Oh, I got what's the point. I had calculated the length before taking the, yeah, because what I was doing is that I was calculating the length before removing the space, so it was returning 9 and then removing 1, and yeah, I was losing precision there. So yeah, now we got it, I think. No, no, true. Okay, this should be 2 false and then 3 true. Space, rerun. And I think I know what's the problem. Data equals to that. Yeah, that was the problem. Because we were still calculating 9 length. So finally, there we go. Now we got 3 true, 2 false, 3 true. So 3 true, then 2 false, then 3 true. Okay? So now I can set, and I should use replace all. That's good. So now I can read and write data into a byte structure. Now, if you recall from Photoshop, our lessons, this is a byte. Now, the next one is a short, and then we will have int and long, okay? So, next one is short. It's fairly similar to this guy, so I will just copy it, Control C, and then paste it. Okay, so, and of course I will have a problem now because this guy is short. Okay, now we have a data of type short and get flag int index, and we are doing the same stuff, int and the boolean value and ints and booleans. We are getting the flag, yeah. So we are setting the flags, no problem there, but here we return short again. That is the only time we need to change the stuff, and this should be okay again. So Control C, and we go for the int this time. So int, and here is int. Okay, and then we will send in long. You may say, hey, why didn't you use generics and delegates? Well, the problem with that is that there is no easy way to do beat shift operatings on generics, and we would need to first uh, serialize that guy, and then what is your problem? Log O O long, not log. Okay, and yeah, there is a problem with that guy because we need to first serialize the object and then get the length of the bytes and then blah 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 blah. And this is, in my opinion, easier way because now you just have some methods, and now if you recall, you have some methods that are completely yeah, you know, we can move them one layer upper. So Control X, Control V, and O. That's not the proper way of doing it because now again we need to use a generic data type. Yeah, there is only way. This is the only way. So we have byte, we have short, we have int, we have long. Now, I will show you that Java itself gives you something very interesting, and that is public static class set, and I will speak about that later, but yeah, come on. No, not that. Okay, there. But what is this guy? Well, This is bit set. And we don't need any of these guys. Honestly, bit set has its own way. So what we can do is we return data dot get the index. Simple, isn't it? And then we say data dot set with the Boolean value. You see that it has itself. So it's index and value. Okay? Here we say data dot set at index of I the value of I. Okay? And here we say data dot set at index of I the value. Toggle the flag. It's very easy. We say data dot flip at index. Get the data. Of course, here we need to send a bit set. And set data, we say this data and we accept a bit set. When we accept an integer, well, we'll speak about that later. First of all, one second, I will be back. Well, what we are doing here is not changing anything because honestly we are accepting data string and then we will go to length and we can replace this guy with this section. We say this dot data come on data work, thank you, dot set. Okay, we say length minus I minus 1 to the data dot character at I equals to 1. Okay, we are doing the same thing. Now here, let me see if we can cast int dot, no, not that. Data dot toString, come on, dot, no. So that's the only part I want to do. Data dot get, no. Okay. This is not good. This is not good. Well, we know that int is 32 bits. Okay. Let me see. Get bit. What I'm doing, I have just that on top. The code is here when we are doing it on int. We get the flag at index. Okay, so we want this part. Control C. Here we say for int I equals 0, I is less than 32, sorry. Okay, I'm accepting int here. No, I will do something else. We will say public No, that's not proper way. That's the only way. So control V. Ah, okay. For uh, int I equals to 0, I is less than 32, I plus plus. Okay. We say this dot data dot set, okay, I comma, so that's the index, and we need the boolean value that is again data and I, and then I. Okay, where is these parentheses going? So set it to I comma, and why is it here? No, there, there, and there. So why are you not happy? We are setting the mask. We are getting the data, bit shifting down and to 1, and what are cannot be applied to int. Oh, oh yeah. Well, what I'm trying to do here is something like this. If I send 0 B11100111, this is an integer, okay? And I want to go bit by bit and set the stuff on the data set and the bit set that we have. So I was hoping that I could get converted this to its bit format and then setting them one by one. Does this data accept any other thing? Oh, I'm derp. I'm really derp. Is, wow, equal to bit mask, no, not bit mask, bit set dot, come on, long buffer, long array, byte, and byte array. Value of data dot cast to long array. And of course it can't be that. So this method will wait until I find a solution. And the solution comes in the form of Google. What would you expect? Get bits of integer one by one. And that should be easy to find. No, not in C#, sorry, in Java. How can one read an integer bit by bit in Java? There we go. Most of the time, if you search properly, int get bit, int n, int k, it returns 5 times, okay, and it ends it with 1, it's equals to 1. Okay, it's completely understandable. Okay, so if we want to implement it, we say first a boolean value equals to. We get the data, we shift click it by a loop that is int, and that is for I, int I equals to 0, I is less than 32, I plus plus. Then we do this by I, okay, and we and it with 1 or 0b1, okay, 1 there, and if it's equals to 1 like that. If you recall, this part is very close to get value, this part, okay, and I should send it 3 times, not 2 times. So where is it? Here we go. Okay, so if it's equals to 1, then we say this dot data dot set at index I comma value. That simple. So now that I have it, can we make it more? Well, we can accept byte. This will be 8. We can accept in short. Then this will be 16. And then integer, that is 32. And then long, that is 64. Yeah, why not? And of course we can set it as string. Now print debug info, that is get flag of I. That should work again. Or we can say this dot data dot get I, just to work with the things that we have. Okay, so as you can see now, we have a bit set that we can send in bit, short, integer, blah blah blah. But if you see, every time we are calling the same method. Now that was the part I wanted. We send in we say private and void set bits. Okay, here we will accept an object called data, and then the integer of count. Okay, so we say if no, first we set it to this thing, we get the loop, Control X, Control V. Then here we say if count is equals to 8, then we cast the data to byte. That should work. And why are you not happy? We cast to byte the data. Okay. Then do the bit shifting. And then doing the AND, and then comparing it to 1. Huh? Oh, Wait, Control X, Control V. I'll be back. Okay, what is wrong here? We say value equals to this guy. There we go. Okay, and of course we set the value. Now why are you not happy? And of course we need to instantiate it so it's equals false. There we go. Now we can send in that and we say that set bits. We cast the data to object data and we send in here 64. Okay, and instead of all of those lines, now I can say okay, this is 32, this is 16, and finally this is 8. And as you see, any type of variables are just objects in Java, so we can remove this redundant casting. There we go. Now, if the count is that we are getting 8, getting bytes, sorry. If it's 16, we cast it to short, okay? And instead of all of that, no, there is no other way. And if it's 32, we cast it to int. And if we are sending in long, then it's long, okay? Now, we have a complete utility there now, okay? And yeah, byte, short, int, long, and set. I think this is a good explanation on how we use bit operators, because on top, even then, when we are using a data set, bit set from Java, we can still use bit operations to set it on with different things here. For example, now I can say instead of that, this is set, okay, and it's equals to new set. Then I send the data and I print the data. But here I can completely get access to data to, sorry, test, come on, type, test dot. And although we have the methods from our class, we should have, okay, we need to cast it to bit set, because that's the same thing, okay? Why are you not happy? Dot, get data, get flag, set data, and you see that it completely works, comma, for example, true. What is the problem? Int boolean, it not accept that. Okay, what is the problem again? Cannot cast this guy to this guy. Oh no, of course we can't cast, but we can get this test dot get data. Yeah, now we can get access to all the operations of bitmask, okay? Bit set, I mean. So, for example, we can set and not. For example, what do you need? 1, comma. What do you need here now? Expression expected, true. No. I didn't work with and not. Let's take a look what it means. And not. Oh yeah, it means a new bit set. Okay, so yeah, we can say bit set uh, a equals to new um, no, come on, bit set. Let's define another one. So test, we say test 2, and now we can say test2 dot get data. So we can use bit set operations on top of each other like that, okay? And to help with our testings. So we have a bit mask now that covers if we want to use a byte, short, integer, and long ourselves, or if we want to use bit sets from Java. I think it's a very complete uh, utility now. What do you think? Well, see you guys in the next episode. Well, honestly, I won't convert these guys because if you recall, before I wrap the episode, if you recall, we have 6 steps. So 6 booleans, 6 bits here, and 1 here, it's 7, okay? So 7 booleans. Even if I convert them to byte, I'm writing an extra 0 every time in every tile entity. So it's not optimized. Okay, so this guy can go boom. And in our messaging, I think, was it here? Well, to do, where are you? Here, rotate the factory. Oh, these guys are from other mod. No, close all. So this is from JPiston, my other project that is open. So JPiston mod lib sources. I don't care about lib sources. Yeah, so that was the only to-do list. Okay, so hope you enjoyed this episode. In next episode, what do we want to do? Well, I think we need to start adding functionality to these guys because this is done. Update entity. Well, receive client event, set active tab, and set and gets. Oh yeah, we have job to do there, but set active tab, get energy, get fluid. Yeah, we have jobs to do here, some jobs, and networking is not going anywhere. So read and write to NBT, we have jobs. Yeah, few things to add because I'm not sure. Did I write everything? No, we still have one more to write and read. So I will add functionality, and most of the functionality will happen in update entity. It may get more than one episode. I'm not sure. Have fun, everybody. Have fun, everybody. Bye-bye.